Okay, number 2 on your test review, we want to identify all triangles in the figure that fit the given description. Number 2 is looking for an equilateral triangle, so we want to find the triangle that has 3 sides marked congruent. 1, 2, 3. And that only exists here in triangle ABC. Number 4, we want to find an acute triangle. Acute triangle is going to have all sides less than 90. You can actually look at a triangle and tell, like here, angle B, that's not acute. Angle D is 90 degrees, so that's not acute. But here, if this is an equilateral triangle, then remember all the angles in an equilateral triangle are 60 degrees. So that means they're all less than 90. So that means it's acute. So triangle ABC again. Number 8 is the triangle sum theorem. It says the sum of all 3 angles in a triangle, is 180 degrees. So we take all of these 3 angles, x plus 5, 3x plus 1, and 2x minus 12, we add them together and they equal 180. I'm going to do the sum within the triangle. X plus 3x is 4x, plus 2x is 6x. A positive 5 and a positive 6, or positive 1 is 6. So 5 plus 1 is 6. Minus 12 is a negative 6. All of that equals 180 degrees. I'm going to add 6 to both sides of my equation. So I get 6x equals 186. Then I divide by 6 on both sides of my equation. 186 divided by 6 is 31. So x is 31. Number 10, it says, well, it gives us a triangle of 2 sides that are congruent, or 2 angles that are congruent, this angle and this angle. So automatically we go across from those angles and mark the 2 sides that are congruent. 2x minus 14 and 4x minus 20. And because those 2 sides are congruent, then that means that they have equal measures. So we say that 2x minus 14 equals 4x minus 20. I'm going to add 20 to both sides. So we have 2x, negative 14, and positive 20 is like saying 20 minus 14, which is 6 equals 4x. I'm going to subtract 2x from both sides, so I get 6 equals 2x, and divide by 2. So I get x is 3. Okay, number 12 says that MA is perpendicular to AH. MA is perpendicular, that means 90 degrees, to AH. So that means that these 2 angles have a sum equal to 90 degrees. So 2x plus 7 plus 3x minus 2 equals 90 degrees. Well, 2x and 3x is 5x, 7 and a negative 2 is 5, and that equals 90. Subtract 5 from both sides. I get 5x equals 85. Divide both sides by 5, and I get 85 divided by 5, which is 17. Number 19, can the following form lengths of a triangle? Why or why not? So if we want to see if it forms the lengths of the sides of a triangle, we take the 2 smallest sides, add them together. It has to be greater than the largest side. So the 2 smallest sides are 9 and 12. And their sum has to be greater than the third side, 18. While 9 and 12 is 21, that is in fact greater than 18. So yes. And why? Because the sum of the 2 smallest sides is greater than the largest side. Number 15 says find the range for the measure of the third side of the triangle. When we're looking for the range, remember we take the third side. It has to be greater than the difference of the two sides, and it has to be less than the sum of the two sides. So the difference would be 19 minus 6, and the sum would be 19 plus 6. 19 minus 6 is 13. So x has to be greater than 13, but less than 19 plus 6, which is 25. So that is the range for the third side, anywhere between 13 and 25. Okay, number 21, we're just looking for labeling. Angle C is a right angle, so this is the symbol that we use when we have a right angle. We put that box there. So we put angle C, a right angle. Angle A is congruent to angle B. Well, if you have two angles that have the same measure, you put an arc on them, or two arcs on them, or the same number of arcs to show that they have the same measures. So angle A is congruent to angle B. AB equals 8, so I just take side AB and I mark it with an 8. And AD bisects CB. Well, if AD bisects CB, here's AD, it bisects CB, so the only way to show that is by marking CD congruent to DB, because D is the midpoint. And this shows that CD is congruent to DB.